In this video, we're going to look at IAL Physics AS Physics Mechanics and Materials. So we're going to discuss what are the main areas that you need to prepare as far as your exam is concerned. We're going to look at Unit 1, different topics that are usually tested in exams, so that whenever you're going to sit for that exam, you'll be in a position to be well prepared. Welcome to Proplan YouTube channel. In this particular video, I want us to have a walkthrough of these predicted questions so that we can be able to see what are the concepts and how are you supposed to approach it. If you are new to Proplan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. You can also check in our Patreon page so that you can be able to download this paper and you walk with me through. Now, going into the paper, something that we need to first look at is how many marks are you going to be tested. This paper is 80 marks and it usually takes you a total of 1 hour 30 minutes for you to answer the paper. And the paper is multiple choice as well as a structured question. The first 10 questions is going to be multiple choice, and then you are going to have the rest of the questions structured. Now, under mechanics and materials, so you are going to have different topics that you should prepare on. Under mechanics, you need to know how to use the equations of motion. That is the SUVAT equations of motion. You need to be aware of this. Displacement time graph, velocity time graphs, acceleration time graphs, you really need to know how to answer those questions. Guys, you need to understand different quantities and also base quantities of different physics concepts. Now, vector quantities and scalar quantities, you need to know how to define them, and giving also examples, because we know vector quantities are those quantities which have both size and directions, but as scalar quantities, they are only described by only magnitude or only size. And also you need to be aware of drawing vector diagrams, which we're going to see. Projectile motion is another area that you are going to be tested. Use of the term terminal velocity. Remember, terminal velocity is the constant velocity an object travels when, especially during free fall, when the weight is equal to the upward force. The resultant force is going to be 0 when an object is moving at terminal velocity. Okay, so understand the concept of momentum, and in this case, we're going to look at momentum in one dimension. Now, once you've looked at that, you need also to know the principle of conservation of momentum, that momentum before collision is equal to momentum after collision, and that is for a closed system. Moment of force, you need to understand also that moment is a product of force and perpendicular distance from the pivot. You need also to understand that an object is at equilibrium if the clockwise moment is equal to anti-clockwise moment, and also force in any direction are also balanced. Don't forget also to go through the concept of work power. So for work is force times distance, and also you need to remember how to calculate the concept like kinetic energy and gravitational potential energy. Kinetic energy is given by a half mv squared, half mass times velocity squared, and then we have the concept of gravitational potential energy. Power is the rate at which work is done. That one you really need to understand, and especially work and power can be related by the formula power is equals to work over time or energy over time. Don't forget to look at concept to do with efficiency, because that's an area that is going to be tested also. Now the next part is materials, because this is mechanics and materials. You need to understand the concept of density, Stokes law, and also Hooke's law is very, very important, because you may be asked something to do with what does a graph of force against extension represent. Of course, it represents the stiffness of the string. Don't forget also to go through stress and strain. Those are areas that are very key. Young's modulus, also very, very important. At the last page of the paper, you are going also to be provided with the formula sheets. And those are the list of formulas you'll be provided that I've shown you here. So make sure that these formulas, you don't have to cram them, but you know how to use them. Yeah, so you can see these are the provided formulas: density, Stokes law, Hooke's law, elastic strain energy. We have Young's modulus and stress and strain, well provided. So the most important part that I want you to focus on is how to use them, because that's now key. Now let's go dive in so that we can be able to see which are the kind of questions I've brought up on this particular prediction. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. Also share this video to your friends and classmates, encourage them to join our platform. And now let's dive in so that we can be able to see what is in store for us. Now, the first question you can see here, you are told all quantities may be expressed in terms of SI base units. Now, you are supposed to state which of the following are the base unit of moment of force. Anytime you are going to be given like a question like this, guys, what you need to remind yourself is that remember the formula. Once you remember the formula, just list the quantities there. Like, you know, for instance, moment, we're going to say is force times perpendicular distance, but we know force is mass times acceleration and distance is d. Then now we substitute the units in so that we can be able to go ahead and simplify that. Then you can see now kg is the unit for mass, acceleration is mass per second squared. So that is why you can see I did that so that I can be able to simplify it further, and I got it to be B. B is the correct answer. And then moving to question 2, we are told that a student used a falling sphere to determine the acceleration of free fall. A camera produces images at constant time intervals. So now something that you need to remember here, distance fallen, yeah, is proportional to the distance fallen is S, is proportional to time squared, because this one we can use the concept of all the formula of S is equal UT plus a half GT squared. Then in that way you can see now when it starts to fall, it means it was 0, so meaning the initial velocity will be 0. Then that's why I'm saying that displacement or distance fallen is proportional to t squared. So if it falls 1 unit in 1 unit time, it will fall 4 units of time, and 3 correspond to 2 units, so which means that our distance here is going to be r. So it's going to be r there, c. A model rocket is launched and moves vertically upwards while still burning fuels to give constant upward upthrust. The fuel runs out. So something that we need to appreciate here, the rocket is going to be is going to have a constant acceleration. Yeah. So if it's having a constant acceleration, this is going to be out, this one is going to be out, and it's going to reach maximum height at time t before falling back to ground. Yeah. So meaning that this is going to reach maximum height at t. Yeah. So which means our answer is going to be C. For question number 3, we're going to take our answer C, because while the fuel burns, thrust is constant and greater than the weight, giving a constant positive acceleration. And then once the fuel runs out, we are going to say the only force will be the downward force, so acceleration become negatives, and that all that happens before the instant time t. So that is we rejected d because you see this is going to happen at time t, so it has to be before time t. Then we have question number 4, whereby we are told that a box was placed at the top of the ramp and released. Then free body diagram for the box is as it moves down the ramp at constant velocity as shown. D is the air resistance, F is the frictional force, R is the normal contact force, and W is the weight. Which two forces acting on the box have, according to Newton's third law, correspond to the forces acting on the ramp? So that is going to be F and R, because friction force is the force exerted by the inclined plane on the ramp. Yeah. Also, R is the frictional force, R is the normal contact force, and F is the frictional force. So both of them are actually corresponding, because according to Newton's third law, the forces that act on the ramp correspond to F and R. Okay. Question 5, we are given question to do with motion graphs, and here, which of the following does the shaded area of the graph represent? So the first thing that you need to do is to identify what is on the y-axis and what's on the x-axis. This is acceleration time graph. So acceleration time graph, the area under the graph represents the change in velocity. But if it was velocity time graph, area under the graph is going to represent the distance traveled. And for also velocity time graph, if it's a velocity time graph, gradient of the line represents the acceleration. So you need to understand that area under acceleration time graph represents the change in velocity during time t, during, not at, during. Which of the following describe gravitational field strength? Remember, weight is equals to mass times gravity, and gravitational field strength therefore is weight over mass, which means weight per unit mass. We have question number 7. Number 7, we are having a spring that is compressed by a force F, and when that force F is removed, then the spring is going to rise. And then we are told that when change in extension becomes 0, the object vertical speed becomes v. So which of the following equation describe the energy transfers? Remember, when this is compressed, it's going to gain elastic potential energy, and elastic potential energy is going to be E½ F delta X. But this elastic potential energy is going to be converted to kinetic energy. At the same time, is going to be converted to gravitational potential energy. So that's why you can see we are going to say it ½ F change in extension is equals to ½ mv squared, which is actually the kinetic energy plus gravitational potential energy at that point. So the correct answer here is going to be B. B is the correct answer at that given point. Moving to question number 8. A lamp with efficiency 0.68. We know efficiency useful output over total input, and this is the useful output energy there. Which of the following can be used to determine E and energy supplied? So meaning that we're going to use 0.68, and remember, it's not in percentage, the ratio. So it's going to be 0.68 is equals to 120 over E, and if you make that subject, you're going to have our answer at D. So this is actually part 1. I'm going to do this paper in 2 parts. So part 1 will be having the multiple choice section, and second last of multiple choice question is this. Then we shall do part 2, guys. So if you have not subscribed, guys, ensure that you subscribe so that anytime I'm going to upload part 2 of this particular video or this paper, you'll be notified. So let's dive in and look at question 9. We are told that when a force F is applied to a spring with stiffness K, the extension of the spring is delta X. A force 2F is applied to the second spring of stiffness 3K. Which of the following gives the extension of the second spring? So the first thing that you need to do is that you need to remember that force is equals to Ke, where delta X is the extension. Therefore, extension can be given by force of F over K. Then now we go to the second spring, because the force that is applied is 2F and the stiffness is 3K. Then this now becomes the extension of this new spring. That's why I denoted with x1, so that you can be able to have a difference from this extension that we were having here. Then you make delta x subject. You are going to have 2F over 3K, but F over K is equals to delta X. So we can be able to substitute F over X with delta X there, and then we shall have the new extension being 2 over 3 of the old extension. So basically that's what we're going to do. Then we have question number 10. Question 10, we are talking about a tractor that pulls a trailer a distance s in time t. The useful power output of the tractor P is P, yeah? The useful output, the power output of the tractor is P. Which of the following question gives the force of the tractor on the trailer? We know that power is work done over time, and the work done is force times distance over what? Over time, right? So if we want to work out force, we're going to say therefore force, because power is equals to force times distance over time, then it means that force, we make force the subject, and that becomes B. Yeah, our answer becomes B. Right, so the next part we are going also to look at is now the structured question. Here we shall be looking at structured question. You can see what the first question that I brought on board is the concept of Stokes law. And of course we have already seen the formula for Stokes, but there are conditions that must apply for Stokes law to hold. Number one, the flow must be laminar. It must be a streamline flow. It should not be turbulent. The sphere must be small and moving at a low speed. If it's big and moving at a higher speed, that's going to create turbulence. The sphere should be spherical and smooth. Those are the conditions also you should take note, and the fluid must be infinite. So that means that this sphere that we are having here, as it's going to be moving, it should not, the sphere should not touch the walls. Yeah. And then if an object is moving at terminal velocity, we know upthrust should be, and the drag force should be, sum of upthrust and drag should be equal to the weight, so that the resultant force is going to be 0. We are going to pick from our part B, and these are the kind of questions that we are going to look at. Let me just show you the kind of questions I've brought on board. We shall have projectile motion, horizontal projectile, vertical projectiles. We shall have question to do with acceleration. Momentum questions will be there. Yeah, so we shall go through this in part 2. So guys, if you are new to Proflearn YouTube channel, consider subscribing, so that when I'm going to upload more tutorials, the next part of this, you will be notified. See you in the next tutorial.